Hey y'all, in this lesson, we're going to be learning how to list out all the possible subsets of a set and how to count the number of possible subsets. One of the easiest ways to list out the possible subsets of a set, so many sets, is to use a tree diagram. And this is just a really nice way to organize your subsets, especially if you have several elements. So remember that for something to be a subset of a set, it has to contain elements in it that live in the other set. Okay. So, and also something that I didn't mention in the previous video, but need to mention for this video is that the empty set, which is the set with nothing in it, is a subset of all the sets. So we're going to use that today. That sounds a little bit crazy. We're going to use it today. Trust me, you'll need it. So I have an example here already written out. We have a set A and B. Those are the only elements in the set. There's two elements in the set. And then we're going to use a tree diagram. And a tree diagram you might have seen before, but it's just kind of listing out all the possibilities. So for example, if you were trying to build a wardrobe with 4 items, you would have like your pants, your shirts, your shoes, or whatever. And then you could figure out how many different outfits you could build with those items with a tree diagram. So you might have seen that in a previous lesson. So we have A and B in the set. And in each branch of the tree diagram, we're trying to decide if A is an element of the subset. And there's only 2 possibilities, either yes or no. So in the first branch, is A an element of the subset? 2 possibilities, yes or no. And then from there, we have the next branch considering B, the other element in the universal set. And so from the first branch, from yes, we could have yes and no, that it's a subset. But also the second possibility where A was not a subset, we have yes and no. And then those are the only elements. So we only have 2 branches here for our tree diagram. But this last little branch, I guess you could call it, is you listing out the subsets. So for the first limb, I'm going to call it, A is part of the subset and B is part of the subset. And that forms your first subset, A, B. And then for your second limb, A is, B is not. And that forms your second subset, just A. And then next branch, A is not, B is. That forms your next subset. And then your last possibility, neither, which forms the empty set. So I mentioned this earlier. This is the empty set. And the empty set will be a subset of every set. So this is just one way to list out your subsets. You could obviously just kind of like think about it and go, well, there's going to be A, B, there's going to be A, there's going to be B, and there's the empty set. That's a possibility. That's fine. But I like to use the tree diagram, especially if you have more than 2 elements. It can get kind of like you might lose some subsets. So for example, in this next one, we have 3 elements. I kept it small because tree diagrams can get a little bit messy. So we're going to set up our tree diagram here. 8 is going to form, I'm going to write a little bit smaller here. 8 is going to be our first branch. 9 is going to be our next one. 10 is our last one. And then here are going to be our subsets. We're going to list those out. And this is just a setup. So for 8, we have yes, it is a subset, and we have no. And I kind of spaced these out because it's going to get a little bit wild here. And then for the next branch, from 8, we have 2 possibilities. And from no, I guess I should say from yes, we have 2 possibilities. And from no, we have 2 possibilities. Now we go to the next branch, and from yes, we have 2 possibilities. From no, we have 2 possibilities. From this yes, we have 2 possibilities. And from this no, we have 2 possibilities. So you can kind of see how this might get a little bit messy. You want to try to keep it lined up. You can abbreviate like I did to make it a little bit easier to fit it all in. But from here, now we have our subsets that we can list out. So I want you to pause it, write those subsets, and come back. So you should have these subsets. We've got 8, 9, 10, 8, 9, 8, 10, 8, and then 9, 10, 9, 10, empty set. So since it's only 3 elements, you could probably list this one without a tree diagram, but I just really like the organization of this. And if you're counting the number of possible subsets, I think I'm getting ahead of myself. I am. Pause, rewind, try these. You're listing the possible subsets. We're not counting yet, we're just listing. So try these 2, pause it, try it, come back and check. Okay, so hopefully you got these answers for your listing out possible subsets. I did not do a tree diagram here. I was pretty confident that I could list those out. I tried here and then I got confused, so I went ahead and did the tree diagram. You can tell it got a little bit messy, but I got them all. So let's count here for a second so that we can figure out how to count possible subsets. And this is going to help us figure out if we hit all of those subsets or not. If we listed them all out, if we know how many there's supposed to be, then we know that, oh, we got them all. So in the second question here, there were 3 elements. How many subsets did we list? 1, 2, 3, 4, 5, 6, 7, 8. So when there were 3 elements, there were 8 subsets. When there were 2 elements, there were 1, 2, 3, 4 subsets. And then pause it for a second. If there was only 1 element, how many subsets would there be? Pause it, write them out, come back. You should have gotten 2 because there's going to be A and there's going to be the empty set. So let's try to see if we can come up with a pattern here as to being able to know the number of possible subsets. We know that when there were 3 elements, that there were 8 subsets. When there were 2 elements, there were 4 subsets. And when there was 1 element, there were 2 subsets. That's what we know so far. Let's look at the powers of 2 for a second. 2 to the first is 2. 2 squared is 4. 2 to the third is 8. Recognize those numbers? So if we want to figure out how many subsets exist, we can raise the number of the elements, or raise 2 to the number of elements in the set. Where n is the number of elements. So if we had a much bigger set, like, I don't know, 8 elements, then we could figure out how many subsets there are by doing 2 to the 8th, or 6 elements, 2 to the 6th, and so on. Then additionally, for proper subsets, now remember, proper subsets, that means that A is a subset of B, but the 2 sets are not equal. So for them to not be equal, we could just say, well, one of those elements is not in the next one. And we would write that as 2 to the n, the number of subsets, minus 1. And take note that this minus 1 is not part of the exponent. It's down, you do 2 to the n and then subtract 1, because for the 2 sets not to be equal, we just need to be missing 1 element. So I want you to pause the video and try these 2 examples and then come back and check your work. So for these, you're not actually listing out the possible subsets, thank God, because they're really big. For part A, there's 6 elements, so you do 2 to the 6th, you get 64. And then for proper subsets, you do 2 to the 6th minus 1, so 63. And if you're using your calculator to do this, I wanted to point out how to do that. So you do 2, and then there's a little caret above or rooftop above the division sign on my calculator. Raise to the 6th, enter, and that's how you got that. And then -1, we can pretty much do. The next one has 9 elements. So we do 2 to the 9th, which would be 512 subsets. I would not ask you to write those subsets out. That would just be mean. And then proper subsets, subtract 1, you get 511. That's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help. See you in the next one.